necessarily a lot of background
Right.
knowledge in.
One thing I've noticed with multiples and factors is that sometimes learners do know the difference.
Just the
They
wrong
get the
name.
wrong labels.
Right.
Greatest common factor, least common
Right.
multiple. And so, and I don't know a strategy to help with that,
Right.
other than to stop and think what the words mean.
But that's like looking at root words is a real struggle for them. I
It
don't
is,
think that
yeah.
a lot of them, especially in a population that has a high level of students, they might speak English and not in ESL,
Right.
but a lot of their homes they come from are not English
Yeah.
homes. And I think that that's a struggle for my students
It
that come
is.
from
Well,
non-English
and
speaking
in our
households.
unit district, we have Brooks that houses the ESL program. However,
Once you pass
Romeoville-
level 3, boom.
But there's
Yeah.
students in Romeoville that their parents refuse to send them
Right.
to a Bolingbrook school, so they drop services altogether, and we're still
Right.
supposed
Right, you still
to.
have to support them.
I mean, sometimes the subtlety of the meaning of these terms is
Yes.
hard for English speakers.
Yes.
And to think about those for whom English is a second language, it's, you know they have to be,
Mhm.
have to.
And if your concept understanding your number sense isn't
Is
there.
fuzzy.
There's so many sixth graders that come in and they don't know what numbers together make 12. I mean,
Mhm.
I have kids that can't use a multiplication chart. Like, we put them in sheet protectors and highlight all the 12s you see on there. And these are all
And
the
still,
factors,
you know.
and there's kids that I have to show them how to use a multiplication chart. Like, they don't, there's kids that a month into school are like, hey, did you notice that if you go down the row, it's skip counting?
Yeah.
Okay.
Yeah.
Like, there's some pretty basic pattern recognition that, you know, like teaching prime numbers, I'll do the Siva Veritasenis, and the idea of crossing out all of the multiples of two, there's kids that struggle with that. And it's,
Mhm.
wow.
Mhm. Let's see another example. Somebody else.
I want to see Patricia's.
We want to see yours, Patricia.
But
I
she's
think I know what yours
excited.
is. I think I know.
Then you can't tell
I've been
us.
peeking.
Torture us.
Patricia since my mom yelled at me. Okay.
These are your examples,
Okay.
These are examples.
Wait, go down there.
and Elma's a little different. Yes.
Okay, good night. These are, I don't know if I'm gonna be able to fit these in here.
Well, show us your non-examples.
Well, you can fit
Can you
up.
zoom out?
Zoom out.
Functions and non-functions.
Oh, it's not what I
Yeah.
was thinking. It's not what I was thinking.
It's a little calculus for you.
Yeah.
That's
Oh,
what I
it's-
thought.
but it isn't, because look at the last non-example on
Oh.
the right. She's zapped us.
Well, what do you notice about, what are some things you notice about the non-examples that's different than the examples?
They're not continuous functions.
They're not continuous.
All right, some of them are just continuous.
Well,
Okay, that's
some
one.
are.
Okay.
Which
But
ones
that
are,
vertical line is what's.
okay.
Vertical
What-
is an function.
What do you know about vertical lines?
That they're not functions, their slope is undefined.
Okay, all
This is
right.
about derivatives.
Something about slope, yes.
Not continuous.
Is this
Okay.
not derivatives?
This is about derivatives.
Oh, love it.
I don't even.
I love it.
Derivatives are just slopes.
Oh.
Slopes. What do you notice about the slopes of the first set, but not the second set? What are some problems with the slopes on the second set? All right, so you said something, Mary, you said something about the vertical line.
Yes.
Vertical
We
line,
know
the
that one's
slope
not
is
defined.
undefined.
Okay, we have undefined, so undefined means doesn't exist.
Right, and then
Okay.
on the left side, I mean, if you took the slopes, if you put each of those line segments, you
What
have two.
What happens at the corner, though? What's the slope at the corner?
Oh,
Yeah.
oh, you're so mean.
Oh, you.
You can't find a slope at a corner.
Corner,
On the
yeah.
V-shaped
Right.
one, you can't
Right.
find a slope? All right, so we couldn't find a slope on the vertical one, we couldn't find a slope at the corner on the second one. How about the praying hands?
Yes.
Where could you not find a slope?
You're asking
At
to
zero.
at zero.
At zero. You're missing a
Okay.
slope at zero. All right, how about the piecewise function at the bottom, where you're gonna have a problem?
Mhm.
At zero, you can't find the slope there. And that other one, the last one with the S curve, you kind of have, that you've got a piece that's similar to the vertical.
It's kind of vertical there.
Oh,
Okay, so
got it,
those all
okay.
have pieces where
They're
they
undefined.
have no slope.
Oh,
Okay.
cool.
All right, you cannot find a slope at certain pieces, and this is the definition of differentiable Those are
a differentiable function.
non-differentiable, these are differentiable functions.
I
Very
love
cool.
it. Do your kids get that?
I never thought to do it, I'm doing it now.
Oh, I love it.
You taught me something.
See, now I get it.
Is it the same idea as continuity?
No,
You get
because
it
some
too.
of them, you can have, differentiable function will always be continuous.
I would do the term
Continuous
differential on a
function
test, and I was like, I don't know what that means.
It's been a while.
Yeah.
Cool.
Very neat.
Thank you. You made my day.
Now we know why you were excited. That was very good.
Yes. Anybody else want to go with that?
I want to do
Go ahead.
algebra.
Okay,
Oh,
let's see.
Yay, Joe.
Yeah, keep my algebra is pretty easy. So the ones on the left
Are
are examples,
examples.
and the ones that are not examples.
Examples have only one term.
They only have one term. You know, that ZP to the negative third power, if I write that as a fraction, I guess I'm seeing two terms, right?
I think that's a two, is that 2p to the negative 3 or is it zp to the negative 3?
That's a ZP.
Okay.
I could,
Well, I definitely see two terms for the bottom non-examples. Maybe it's not terms, guys.
I don't think
Maybe
it
it's
is.
not terms. You want to write us another example or non-example?
no, someone already said it.
Polynomials or
Someone
polynomial?
already said it.
Okay.
Someone already said it. Like right away, actually. And this is like one of the basic questions that we ask, and like you should be getting 100 on.
Oh,
What unit would you be
Just that it's a
doing
Yes.
this?
monomial?
This would be polynomials.
is this ninth grade or tenth?
Ninth grade.
Ninth grade, okay.
So this is the base, I'd be teaching this when we define polynomials.
Okay.
A monomial?
Yeah, the examples are monomials.
So everything in the front is the examples, they're all monomials and everything else.
That's perfect.
The other one is not monomial.
Yeah.
So, you know, basically, we got the idea figured out, then we hung the term on it. After we were sure what it meant, then we put the term on it. Thank you. Beautiful.
Thanks for
Anyone
letting me
else?
share.
I have one, we'll see.
I think definition of polynomial would be good here
Yeah,
too.
that would
Yeah.
Yeah,
Poly-
yes.
yeah.
Okay, now, if I had a template for figures, it would be better. So just,
That's pretty darn good.
Ah, that's amazing, yes. Pull it towards yourself, yeah.
Similar and congruent.
yes.
Sorry.
Ah.
Similar.
Yeah, you can tell,
Oh,
you can tell,
good,
yeah.
that's
It's
great.
that show where they buzz in, that's what.
You know what you could do with that? Put that back up there. I'm thinking about the ones that are congruent. Those are on the right, right? You could actually do some congruent figures and actually
are
rotate some of those
similar.
Right,
figures.
yeah.
That would be fun.
Yeah, so it makes it a little tricky. Thank you. I think that's a great way to distinguish congruent.
Especially when they're
Uh-huh.
just similar.
Oh, yeah.
Turn the figures, yeah.
Another example, okay, example.
Oh, I think we have to.
Oh,
Does
direct
anybody wanna
versus
go over and get
inverse,
drinks?
direct variation versus.
Grab something to
Yes,
drink
go
before they
grab-
go.
Yes.
If you want something to drink, we're telling folks to
Go right ahead.
to
Yeah.
grab something before they're gone.
To take home, you don't have to drink it here, just take it home.
Oh, right.
If you're taking their class, more diet would be fantastic.
I'm sorry?
If you take their class, more diet would be fantastic.
More diet drinks.
Who's taking the brownies?
You are.
I got a bunch of
So these are examples of functions that have to be listed.
Yeah.
And is there a name for those?
Direct variation.
Oh,
but-
of course, yes.
But Common Core does not use that expression. I think it would
They
be
do
more
in
where,
7th grade.
it would be more where the y-intercept, where the initial value is 0 versus the initial value being something else is how we would look at it in 8th grade. I don't know what they do
Thank
in
you.
7th
I
grade.
like
7th
that.
grade, we call it direct variation.
Okay, I didn't see that one, can we see it?
Is that what Common Core calls it
I wanted to
too?
know.
Was it increasing versus decreasing?
No, no.
I just,
So
we
then I
did
can
know,
put
it's
this
under
in.
weight.
Get a chance to do it.
Yeah, when they're waiting for 0?
Yeah.
Okay, so y
Both of them do
intercepts.
0.
Oh, okay.
Oh, y intercepts.
Better, we did a whole bunch of things we didn't need to do.
Oh, yeah, no, all of
Because
that
we
should
just
be,
had
is being
huge
pushed back
conversations
to
how there
8th
is a
grade.
direct
So this could be direct
Direct
variation,
Direct variation.
inverse variation.
Yes.
indirect versus indirect.
One was
They just don't call it
funny
direct,
is,
they have
Right.
straight lines and indirect.
Right, exactly, they don't call it direct
I
relation,
won't go
because
on my
Christie
tangent
made a
about
huge point of
what we're allowed
telling
and not
us,
allowed to
don't
do in
use that, and then
eighth
you
grade.
said it wasn't something.
No more
That's
standard
the one
form,
now. It
that's for
says
sure.
teach
You
them
know,
that word.
Right.
that's why I really wanted that question that came up yesterday to come out, and I don't want us to diverge, but if you're teaching the surface area and volume of a prism and a pyramid, wouldn't it be natural to do a cylinder? That question didn't come up. The underlying concepts may be the same for a cylinder and a cone, but we didn't get to ask her that. Maybe we'll
But
email her
remember how
that.
she also said though that in some cases the first year is just to expose
That's
them
true.
and then
That's
that we
true.
build on that?
Yes.
That-
Yes,
that-
so that may be.
I have no idea, not a geometry queen.
But again,
But they're so like.
Right.
It's
regimented.
If you were
It's not
really
fair.
teaching about the concept of it, then
You would
it's the
develop that.
same
You
would think it'd be
concept.
right there.
So
It
I
is.
wouldn't show them just a piece of it and not, I think it's important to show them multiple ways that you can use that same concept.
I hear you on that, and I think we as teachers have some decisions we have to make. Notice me riding the fence on this. Some decisions we have to make about those things. Okay, quickly changing the subject, another example. You didn't record that, did you?
I'll cut it out.
Cut that out, erase that.